September 12th, 2025. Celestial observers detect an impossible phenomenon. A colossal entity hurtles through the void from interstellar space. Its luminous trail spans a width 5 times that of a full moon, eclipsing anything witnessed since Oumuamua. Within mere hours, a second cosmic traveler is confirmed. Both entities are on a direct trajectory towards the Sun, poised for a close encounter mere weeks apart, yet originating from diametrically opposed celestial quadrants. The probability of this dual cosmic arrival, according to experts, is astronomical. The official explanation posits twin comets. However, the available data strongly suggests a deliberate fabrication. A more significant artificial object now enters our solar neighborhood with an unexplained purpose. Is this an accidental interstellar journey or the initial phase of a covert operation triggered by our own presence? The resolution begins here. On September 12th, 2025, the SH spacecraft's S-SWAN instrument registered an anomaly that caused astronomers to freeze. A novel celestial body, brilliantly evident, blazed across the solar system. Within hours, preliminary data began to stream in. A tail stretching nearly 2.5 degrees across the sky, equivalent to approximately 5 times the apparent diameter of a full moon. Such a magnitude is unprecedented for a newly identified comet. Initial photometric readings placed its apparent magnitude at 7.4, bright enough to be visible through modest backyard telescopes and even some binoculars. The news disseminated rapidly, prompting amateur astronomers to eagerly confirm the satellite detections. In Australia, a mere 2 days following the satellite alert, an observer captured a striking image of the object. A luminous streak so extensive it threatened to spill beyond the camera's frame. By September 13th, the International Astronomical Union had officially acknowledged the discovery, designating the celestial body C2025R2 with the designation SWAN in tribute to the instrument that first detected it. Within a single weekend, both professional and amateur astronomical communities became intently focused on this phenomenon, exchanging imagery and brightness estimations across various hemispheres. Its sheer size and brilliance ignited widespread speculation. The majority of comets discovered in contemporary times are faint, often requiring powerful telescopes for observation. Swan, conversely, was discernible to anyone aware of its position. Its tail cut a path through the constellation Virgo, intensifying in brilliance as it approached the Sun. The initial response was not solely excitement, but profound disbelief. This was no ordinary icy visitor from the distant reaches of space. The parameters did not align with any recent astronomical precedent. As reports accumulated, a singular realization emerged. Swan was dominating the inner solar system physically, in a manner not observed since the era of Hale-Bopp, or even earlier. The amateur community, frequently the first to notice changes in brightness or unusual behaviors, was already engaged in discussions regarding the potential impetus behind such an extensive and luminous tail. For the moment, the object's magnitude, vividness, and speed rendered it impossible to overlook. As the world's telescopes meticulously tracked its trajectory, the fundamental question shifted from its identity to the reasons for its current arrival and whether its timing was merely the prelude to a far more enigmatic scenario. C2025R2, now officially designated SWAN, is not the sole newcomer commanding attention this October. Merely days before its detection, another object, 3I Atlas, was already en route, making its own approach from a distinctly different sector of the sky. SWAN's trajectory can be traced back through Aquarius, while Atlas emerged from the direction of Sagittarius. On a celestial map, these two arrival vectors are separated by more than a quarter of the observable universe. Yet, both entities are projected to reach their closest solar proximity, known as perihelion, within the same 10-day interval. For SWAN, this apex occurs around October 20th, at a solar distance of approximately 150 million kilometers. For Atlas, it is October 17th, just 3 days prior, skimming past the Sun at roughly 203 million kilometers. This positions their perihelion points a mere 50 million kilometers apart, a distance less than that of Mars's closest approach to Earth. This is not simply a matter of overlapping dates. The geometric configuration is striking. Both objects occupy orbits with steep inclinations. Swan's path tilted more than 60 degrees from the ecliptic, and Atlas nearly perpendicular to the plane of the planets. Their approach angles are so divergent that by chance alone, the probability of both traversing the inner solar system at nearly the same time and at such similar solar distances is exceedingly minute. Astronomers who monitor long-period comets and interstellar objects are accustomed to random arrivals scattered throughout the calendar, with perihelia spread over months or even years. However, here, the two most brilliant new objects of the decade are converging on the Sun in near synchrony, each from a distinct celestial origin. The temporal aspect adds another crucial element. As both Swan and Atlas sweep through their closest solar passage, Earth's telescopes are effectively rendered blind. From October 8th to the 18th, the Sun's intense glare obstructs direct observation, creating a blackout period that encompasses the critical days when any unusual activity would be most discernible. This signifies that the moment of closest proximity, both to the Sun and to each other, occurs just beyond our observational reach, precluding any possibility for ground-based observers to witness unfolding events in real time. The simultaneous arrival of two such objects from widely disparate origins, reaching perihelion within days of each other and at nearly identical solar distances, all during a period when the Sun itself conceals them from view, defies conventional expectations of random chance. In the language of orbital mechanics, this constitutes a corridor, a narrow nexus in space and time that both entities occupy concurrently. Whether this represents coincidence, an unseen connection, or a deliberate arrangement remains an open inquiry, but the geometric alignment alone is sufficient to give even the most skeptical astronomer pause. Three-Eye Atlas initially garnered attention not for its luminosity, but for its deviation from established norms. Early spectrographic analyses from the Atlas Spec Lab group revealed something that triggered immediate concern: a composition dominated by nickel with virtually no iron present. This contradicts everything known about comets, which invariably exhibit mixtures of iron and nickel in their vaporized components. The assertion was so unexpected that some laboratories promptly requested data reconfirmation. This calibration controversy subsequently spread to astronomy forums, initiating a series of independent reviews. The debate intensified with subsequent measurement rounds. Instead of the characteristic water vapor signature, the coma of Three-Eye Atlas emitted carbon dioxide at rates 5 times higher than water. The 4.3 micron CO2 spectral line dominated every analysis, while H2O registered barely above background noise. While rare, this is not entirely unheard of for comets originating from extremely cold regions. What could not be readily explained was the behavior of the tail. Observers tracking Atlas's motion noted a distinct pattern: 3 separate accelerations, each approximately 2 weeks apart, coinciding with abrupt shifts in tail coloration. The initial surge was recorded on July 29th, the second on August 14th. Photometric data indicated a sudden increase in brightness, while the spectral slope transitioned from reddish to nearly neutral, and then back again. These so-called delta-5 pulses were not gradual, like the steady push from solar heating. They occurred rapidly, then subsided, as if the object had deployed propulsion. Peer reviewers raised objections, highlighting the potential for calibration drift or hidden systematic errors. However, the Atlas Spec Lab team defended their findings, asserting that the timing and magnitude of the pulses were consistent across independent observatories, from the Abaro Tracker Network to Bill Gray's Distributed Telescope Array. The numerical data did not align with typical outgassing phenomena. The tail's CO2 composition appeared to modulate in sync with each acceleration, a behavior some termed thrust mix modulation. What truly fueled widespread speculation was the energy estimation. If the observed accelerations were indeed real, the implied power source within Atlas would need to supply approximately 10 gigawatts, roughly equivalent to the output of 10 large nuclear power plants. This far exceeds the capability of any known comet nucleus. The prevailing scientific consensus still posits that natural processes can account for the majority of the observed data, but the inconsistencies, particularly the nickel spectrum and the stepwise accelerations, have kept the hypothesis of an engineered object in contention. For the present, the Atlas anomaly file remains open, with each new data set fostering both skepticism and conjecture. Swan, now simply designated as such, occupies a category of its own. The figures tell the story. A tail spanning 2.5 degrees, a peak luminosity rivaling the most notable comets of the past century, and a core that, if the most extreme estimates hold any validity, could be generating 10,000 gigawatts of energy. This represents a raw output exceeding Earth's entire power grid, and then some. However, it is not solely the scale that has captured public attention. It is the claims emanating from the fringes of the astronomical community, assertions that Swan is armored, shielded, and powered in ways that challenge the boundaries of current scientific understanding. The initial murmurs began with reflectance data. Standard comet nuclei scatter sunlight predictably, but Swan's core reflects light with a distinct metallic signature. Some amateur spectroscopists contend that this aligns not just with nickel, but with a nickel-cobalt alloy, materials chosen on Earth for their exceptional strength and resistance to corrosion. The term nickel-cobalt hull began circulating in online forums and late-night podcasts, fueled by the object's persistent refusal to disintegrate or dim as it approached the sun. Subsequently, reports emerged of an optical anomaly, a consistent silvery halo surrounding the nucleus, fluctuating in pattern and intensity. To some, this resembled a plasma envelope, a form of electromagnetic shield capable of deflecting solar wind and cosmic debris. This is the origin of the Fortress moniker. Unlike 3i Atlas, which behaves more like a drone, swift, agile, and remarkably efficient, Swan presents as a formidable tank, steady, unyielding, and seemingly invulnerable. Its tail, already of record-breaking length, exhibits pulses of microthrusts that defy conventional outgassing models. Photometric analysis reveals subtle rhythmic alterations in tail direction, suggesting the object is making course corrections through precisely timed plasma bursts. Each pulse registers as a momentary spike in the brightness curve, and the pattern repeats with a regularity that makes attributing it to random surface eruptions difficult. The orbital parameters introduce another layer of intrigue. Swan is on a trajectory that will bring it around the Sun once every 22,554 years. This is a cycle so extensive that it nearly coincides with the last ice age. The implication is staggering. If this object is indeed artificial, it has been following a predetermined course for a duration exceeding the existence of human civilization. Furthermore, it arrives now, concurrently with Atlas, within the same solar corridor, during a period when Earth's telescopes are obscured by the sun's glare. The probability of all these factors converging by chance is infinitesimally small. All of this contributes to a growing sentiment that Swan is not merely another comet. Its exceptional luminosity, indications of advanced shielding, the potential armored structure, and the sheer magnitude of its energy output position it as the most formidable object to have entered the inner solar system in living memory. Whether it is a fortress, a probe, or something entirely different, Swan has compelled astronomers to revise their established principles and open the door to theories that, until now, belonged solely to the realm of speculative fiction. Every significant anomaly recorded for Swan and 3I Atlas has shifted the focus from their identities to their potential objectives. When two massive entities, one on a 22,554-year return trajectory, the other on a hyperbolic, possibly interstellar path, arrive in close temporal proximity, the likelihood of pure chance plummets dramatically. The timing, the geometry, and the blackout window have collectively fueled a surge of mission-related theories. One possibility appears relatively conventional, at least by cosmic standards: a scheduled maintenance or refueling operation. In this scenario, the Sun serves as a cosmic pit stop. Both objects could be engineered to utilize solar energy or magnetic fields for recharging, data exchange, or even systems diagnostics. This concept is not far-fetched in the context of deep space mission planning. On Earth, solar flybys are a standard practice for gravitational assistance and energy boosts. If these objects are indeed probes, the Sun represents the logical location for replenishment or information transfer. Another theory is less benign. The close rendezvous could signify an intervention, a meeting to retrieve or neutralize a malfunctioning unit, or perhaps a contest between rival factions vying for a resource. The estimated power levels for each object, Atlas at approximately 10 gigawatts, Swan at a remarkable 10,000 gigawatts, suggest energy reserves sufficient for active maneuvering, not merely passive drift. The stepwise accelerations and tail modulations observed in Atlas, along with the microthrust pulses detected in Swan, indicate a level of control consistent with a mission profile rather than random outgassing. There is also the possibility of an audit chain scenario. Oumuamua in 2017, followed by Atlas and now Swan, could represent progressively sophisticated responses to a century of Earth's radio transmissions. Each subsequent arrival would be a more advanced probe sent to investigate, gather data, or escalate contact. Within all three theoretical frameworks, the Sun is not merely a passive backdrop. It functions as the power hub, the rendezvous point, the beacon. The evidence does not definitively resolve the debate, but it compels a new line of inquiry. If this is indeed a mission, what is its ultimate purpose? A 22,554-year orbital period is more than just a numerical value on a chart. It is a cycle that extends deep into the last ice age, a time when the world bore little resemblance to its present state. Around 20,000 BCE, glaciers covered a substantial portion of the northern hemisphere, and the climate was undergoing shifts that profoundly shaped the earliest chapters of human civilization. That same epoch left its imprint in the ice cores of Greenland and Antarctica, where layers of dust and subtle chemical alterations hint at abrupt, dramatic celestial events. Some researchers have noted that these layers correlate with periods when bright, long-period comets may have passed through, leaving behind not only debris, but also narratives that might have been passed down through generations. Central to this notion is a location known as Göbekli Tepe, a site in southeastern Turkey constructed over 11,000 years ago. Its stone pillars are adorned with carvings of animals and abstract symbols, including motifs that some interpret as depictions of celestial object trajectories, possibly even comets. A limited number of theorists propose that these carvings record cycles far exceeding a human lifespan, perhaps even marking the recurrence of something akin to Swan. The prevailing scientific view is considerably more cautious. Both archaeologists and astronomers caution that these connections are speculative at best, based on pattern recognition that could equally be attributed to chance. The debate is heated, with critics pointing out the absence of direct evidence linking these ancient monuments to specific astronomical cycles. Nevertheless, the timing is difficult to disregard. If Swan indeed returns every 22,554 years, its most recent passage through the inner solar system would have occurred precisely as the world was emerging from the grip of glaciation, at a pivotal moment when human culture was taking its initial steps towards constructing monumental structures and charting the heavens. Whether this represents coincidence or something more remains an open question, but it imbues an already extraordinary event with a layer of mythic resonance. Ultimately, the narrative of Swan transcends mere numbers or orbital mechanics. It speaks to the possibility that the sky's most infrequent visitors have been intrinsically woven into the very fabric of our origins. From October 8th to the 18th, every major terrestrial observatory faces an enforced cessation of operations. Official schedules cite the period as solar conjunction downtime, but behind the scenes, the restrictions extend further. Internal directives from U.S. Space Command and the European Space Agency mandate that teams cease all radar and high-resolution imaging of both Swan and 3I Atlas during this blackout period. Certain proposals for alternative observational coverage are rejected without explanation. Requests for raw data are discreetly rerouted or subjected to delays. A select few reviewers of telescope allocations, speaking anonymously, describe explicit instructions to refrain from public statements regarding either object until after perihelion. The consequence is a mandated silence at the precise moment when the two most peculiar visitors in decades traverse the sun's intense glare, leaving only a narrow band of independent astronomers and amateur networks to bridge the information void. When the blackout orders were issued, official channels fell silent, but the amateur networks did not. Bill Gray, a seasoned tracker renowned for his open-source orbit calculations, initiated the mobilization of a distributed network of backyard astronomers and smaller observatories. His appeal was disseminated across public forums and encrypted chat rooms. Maintain vigilance on the sky, meticulously record every flicker, and share the raw data before it vanishes. The Abaro Tracker Collective in Spain and Portugal began consolidating wide-field sensor feeds, while information leaks from private astronomy groups indicated the development of improvised plans to circumvent the blackout using radio telescopes and even repurposed weather satellites. With government agencies operating off the record and major observatories effectively locked down, the grassroots effort emerged as the sole safeguard against a complete information vacuum. Anyone possessing a telescope, a radio dish, or access to open-source tracking software could participate. The blackout window was not merely a challenge, it was an implicit invitation. If you seek answers, you are now part of the investigation. When Swan and Atlas re-emerge from behind the sun, the initial signals might originate from someone's backyard rather than a government laboratory. The facts are unequivocal. Two anomalous objects entered the inner solar system in tandem, defying statistical probabilities and raising questions that no agency has yet addressed.